Hello learners, welcome to our Age Blush Visual Academy. We are still looking at electric circuits and in my previous presentation, we were looking at a parallel circuit. And I promised that in my next presentation, I'm going to look at a circuit that has got a parallel connection and a series connection as well, whereby two resistors are connected in parallel and in series with another resistor that we can call R3. So that's the circuit that we are going to look at. And I'm also going to introduce what is called the Ohm's law. I'm going to write the Ohm's law for you, and I'm going to show you the formula that we are going to use, which is actually the Ohm's law formula that we are going to be using. Right. So our sub topic right now that we can write to start with our lesson, we just write Ohm's law. Right. Ohm's law. Uh, I hope my handwriting is clear. Right. So that's Ohm's law that I'm going to introduce because we are going to use it for our calculations. Right. What does Ohm's law say? In other words, the Ohm's law is going to guide us through most of our calculations under electric circuits. Right. So Ohm's law, it says the potential difference. It is very important for you learners to know this Ohm's law, though we don't uh, use it that much in grade 10. We use it more grade 11 and grade 12 according to our CAP syllabus. So the Ohm's law says the potential difference, right? The potential difference over a resistor over a resistor is directly proportional to the current flowing to the current right to the current flowing through the resistor through the resistor provided the temperature of the resistor remains constant. So in other words, we are saying the Ohm's law only stands, or the Ohm's law is only correct when the temperature of the resistor remains constant. And when you look at the definition of the Ohm's law, you can actually derive a formula which says V is equals to IR, and this is our Ohm's law, right? If we can make R the subject of the formula, or if we can make I, which is current, the subject of the formula, you still realize that current and resistance, they are inversely proportional. Is that okay? So it confirms what we have been talking about, whereby R represents your resistance, and your resistance is measured in ohms, or we just write that symbol, and this is your current, which is measured in ampere, and this is potential difference, and potential difference is measured in volts. So that is Ohm's law that we are going to use for our calculations. Right. Now, in light with this Ohm's law, this formula, I want us to look at a circuit, the one that I promised, that has got a parallel connection and another resistor which will be connected in what? Which is going to be connected in series, and we look at few calculations on that. I'm going to draw a circuit diagram here and we do some calculations on it. So we have our power supply here, and do not forget that we are looking at conventional current, whereby current flows from the positive terminal to the negative terminal. So suppose we have got an ammeter here, right? And from that ammeter, we have got okay, we have got another ammeter there, and we have got another ammeter there, and we have got resistor, we have got a resistor there, and then they link here, and then we have another resistor here. I think now it makes sense. Like I promised Kuri, we are going to look at two resistors in parallel but in series with another resistor. So this is the power supply, and there we have our switch, and our switch is closed so that current can be able to flow. Right. I want to put values to the resistors. Let me say this is 5 ohm resistor, this is 6 ohm resistor, and this is 3 ohm resistor. And we want to find out how do we calculate the total resistance uh, of this circuit, and also how to determine the different voltmeter readings. Right. So let me put the current, the total current, and let me call this AT because it measures the total current, right? And this one A1 and this one A2, right? As simple as that. Now, I have got a voltmeter here, which is across the power supply, and I've got another voltmeter here, which is V1, and I've got another voltmeter here, which is V2, right? Is that okay? Now, what is the first question that I want us to look at? Suppose the current or the ammeter, the 80, which measures the total current of the circuit. I'm sorry, my VT is not clear, but you can see that I wanted to put a voltmeter there. So 80 reading, let's say, is 3 ampere. That is the total current of the circuit. And remember what we said previously, that in a in a parallel circuit, current divides, right? But in this case, we have a parallel connection of 6 ohm resistor and 3 ohm, they are in parallel, but they are in series with 5 ohm resistor. Is that okay? So A1 reading, you can see A1 on the diagram, and A2 reading. If you put those two readings together, they must give you back your 3 amps, because that is the total current. Right. So what is the first question that I want to address here before I look at a lot of things and confuse you learners? Right. So let me divide my page into two parts, and allow me to do calculations. The first calculation that I want to look at, which is item A, is calculate the total resistance, right? Calculate the total resistance, right? Total resistance of the circuit. Is that okay? So how do I calculate the total resistance of the circuit? Because I've got two resistors in parallel but in series with another one. It makes everything a bit complicated there. But here is the method. Total resistance is RT is going to be equivalent to the parallel resistance plus that other resistor which is in series, which we can call RS. So the first thing we need to do when we have such a circuit, Grade10, we need to come up with our parallel resistance first, using the previous method that I've showed you in our previous presentation. Then when you get that RP plus the one that is in series, you get your RT. Is that okay? So I need to determine my RP first so that I can be able to add it to RS, and then I get my RT. So 1 over RP, I'm calculating RP now, is equals to 1 over R1 plus 1 over R2, which is equals to, what is my R1? 6 ohm. So it's 1 over 6 plus my R2, which is 3. And this is all equivalent to. We need a calculator, friends, so that we don't confuse ourselves. So this is 1 over 6 plus 1 over 3. 1 over 3. 1 over 6 plus 1 over 3, then we get 1 over 2, right? But we are not looking for 1 over RP, we are looking for RP. Therefore, we reciprocate. RP is equals to what you have done to the left hand side, you do it to the right hand side. So it was 1 over RP, and it becomes RP over 1, which is RP. So 1 over 2, it becomes 2 over 1, which gives us 2. Right, which gives us 2. So the parallel connection is 2. That is the total resistance for the parallel connection. But that's not the answer. We are looking for total resistance, which is RT. Therefore, RT is equals to RP plus RS. So RT is equals to, our RP is 2 plus our RS, which is 5. So the total resistance of the circuit is 7 ohm. That's it. So you must determine your RP first, right? And then you add it to RS, the one which is connected in series. So I'm done with the first question, where I have to determine the total resistance of the circuit. What is the second thing that I want us to look at here? I want us to determine A1 reading and A2 reading, and then I will just explain to you how you can calculate V1 and V2 because of space on my page. Right. How do I determine A1? So you put the title A1. So I want to show you a method of ratios when you have got two resistors in parallel, or when you have got two pathways. I want to show you a method of ratios. So what you do, you interchange the resistors. You take 3, you put it on top, right? You take 3, you put it there, up there, and you take 6, you put it down there where there is what? 3. So if you want to determine the reading for A1, remember A1 is not the total current of the circuit. The total current of the circuit is 3 amps, which is going to divide into A1 reading and A2 reading. But when you add A1 and A2, they must give you back your total what? Your total current, right? Because remember we said on a parallel connection, current divides. But how does it divide? Higher resistance, less current. So in this case, before I even do the calculation, 6 ohm resistor must get less current because it has got higher resistance. So for A1 reading, instead of using 6 ohm, I'm going to use 3, right? Over the total ratio, which is 6 plus 3, which is 9, times the total current, which is 3, right? And this gives me 3 times 3, it's 9, right? Over 9, which gives me 1 amp. So in other words, A1 reading or that pathway for 6 ohm is going to get 1 amp or 1 ampere. Now, if you are doing your maths and if you are following the lesson closely, if the total current is 3 amp and A1 is taking 1 amp, so it means A2 takes 2 amp, because 2 plus 1 gives you back your 3. Or if you just want to prove it through calculation, it's still allowed. For A2, you no longer use 3, you use 6 over total ratio 9 times the total current, which is 3. That gives you 18 over 9, which gives you 2 amps again. So in other words, A1 reading is 1 amp and A2 reading is 2 ampere. Putting the two together, they give you 3 amp, which is the total current of the circuit. Now, we go back to our basics. Is it still true that resistance and current, they are inversely proportional? Yes, it is still correct. Because when you look at this calculation now, when you look at it now, 6 ohm is much higher than 3 ohm. It gets 1 amp, which is lower current. And 3 ohm, lower resistance, it gets 2 amp, which is higher current. So let me show you finally how we can determine V1 and V2. Now, for us to be able to calculate V1 and V2, we need to use the Ohm's law. This is where the Ohm's law comes in now. So for V1, and this is V2. So for V1 calculation, we are going to use the Ohm's law, which is V is equals to IR. We use what we call corresponding values, right? So for V1, we only use current which flows through that pathway, right? Can I repeat that? For V1, we only use current which flows through that pathway. In other words, we use our A1 reading, which is 1 amp, times we only use the resistance of that path, not the total resistance, but the resistance of that path, which is 6. So V1 is equals to 1 times 6, which is 6 volts. That is your V1 reading. Then V2 reading is equals to IR. We use the Ohm's law again. So V2 is equals to, what is the current that passes through that 3 ohm pathway? In other words, our A2 reading, which is 2 amp, times the resistance of that path, which is 3. So V is equals to 6 volts. Now, something very interesting here that we can actually note. The reading for V1 and V2, they are the same. Why is it the same? It is the same. It is the same because it's a parallel connection. Remember, we said on a parallel connection, potential difference is the same, but the current divides. Is that clear? So this calculation is correct. Is that fine? So in my next presentation, since I've already highlighted how we can calculate total resistance when you've got a parallel and a series connection, and I've shown you how to use the Ohm's law. So in my next calculation, I'm going to introduce another variable, which is VT, or the terminal potential difference. The potential difference across the power supply or across the battery. And that is going to be our fully fledged question on electric circuits. And from there, it will be just revision, but otherwise we would have covered also the major basics of our electric circuits. Thank you so much for watching, and thank you so much for joining us. We'll continue to make this presentation. So this is our lesson 4 on electric circuits, grade 10. So we'll continue to make our lesson, and please make sure that you follow our lesson so that we can be moving together. Thank you for watching Edge Blush Virtual Academy. You, we hope to meet you again in our next